told, first we have to design our model in CAD. Then we have to assign property. Then we have to do meshing. Then assembly. Then we have to apply our boundary condition. Then we have to assign solver. In the last, we are going to check or we are going to study result. Abacus is a FES software similar like ANSYS and other console multi-physics software. In Abacus, we can do so many things like structural analysis, civil, mechanical, offshore, onshore, whatever we want, we can just do in Abacus. So in Abacus, how we can first, I'm just going to give you simple idea by through PPT. Then we will go to our software. So in Abacus, we are having this. This is we are calling model tree. So we have to start with part. We are having different model like first part, property, assembly, step, interaction, load, mesh, job, then visualization. So we are having around the 8 to 9 module inside module tree, and we have to follow step by step so that it will be easy to understand. Hello, sir. Can you hear me clearly? It is okay. Okay, fine, sir. Then Abacus, they are having different versions. So first one they are having Abacus CAE. CAE means they are having simply for CAD design, like complete Abacus environment. Then we are having Abacus Standard, Abacus Explicit, and Abacus Viewer. So they are having different module in Abacus. Mostly we are working on Abacus Standard because static and because of we are doing static and slow speed dynamic problem. Yeah, we can do. Yes, yes, we can do, sir. I will teach you when we go to our software. I will explain you how we can do. Okay. So first we will start with for example, I will take simple cantilever beam. I will just open my camera. That will be easy. Yeah, that's fine. So first, how we are going to model any structures. First, I will take simple cantilever beam in Abacus, simple 2D planar beam. Then we will define our material, different property like section, step, how we can apply load, how we can select our solver. Like for example, I want to do dynamic analysis. Maybe I want to do some static analysis. So we have to define solver in step module, and then we have to define our boundary condition, loading, meshing, everything. I will go step by step. So in first step, we have to create our geometry. We have to draw our CAD model. So we have to create our geometry. Geometry can be our model can be 2D, 3D, 1D, and it depends on our model. So we have to do geometry creation. Okay. Then next step, after creating our model, we have to define property mass, for example, density, Young modulus, Poisson ratio, all the property of that module. Okay, so we have to define in this section material and section assignment. I will do when we are going to our software. So we have to define our material, property, and section assignment. And third step, what we have to do, we have to for example, I'm having part for example, I'm designing one T joint. So first I will have vertical member, second one horizontal member. So how we can assemble? So we have to do an assembly module. So we will assemble this two member. Then fourth one, we have to define what type of analysis I'm going to do. I want to do dynamic, I want to do static. Simply, I want to do modal analysis. I want to get some frequency, mode shape. So we have to define step, which type of model, which type of analysis we are going to define, and we have to define solver, which solver we are going to use in our this assembly module and step definition. After defining our material properties, assembly and step, we will go to our boundary condition. The for example, I'm having one cantilever beam. So one end it is free and other end it is having fixed support. So we have to define boundary condition plus loading. It is point load, it is distributed load, it is wave load, and it is earthquake. So we have to define our loading in this load and boundary condition. It is okay, sir. It is now it is till now fine. Okay. Yeah. Yes. 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 That. Yes. And that I got it, sir. I got it. So this one, like we are going to define different mesh type. So in meshing model, we are going to define our mesh. Like for example, near to joint, I need very coarse, like fine mesh. Beyond this joint area, I need coarse mesh. So that one we are going to see how we can define. Then we are having different like type of meshing element. Like for example, our structure is simply 1D, so we will use beam element as a line element. For example, our structure 2D, so we will use like these are called like triangular, uh, quadrilateral cell element we are going to use. For example, our structure is like 3D, so we are going to use like hexagon, tetrahedral, all the meshing element we are going to use for our structure. Then in the last step, what we have to do, we have to create our job. Like we will give command to create job, then we have to submit our job. After submitting our job, we are going to monitor status. Like we are going to check our simulation it is running or any error is coming. Then we can see in by using different file extension like .sta, .dat, .msg file. These are the some file extension that we are going to check our file status. In the last module, we are going to visualize and we are going to extract information from that our module. So I'm working on this Abacus last 3 years, and I seen some error commonly we are doing. For example, sometimes we are missing assignment section, sometimes we are having mass error, sometimes we forgot our step. So we have to remember all these steps we have to follow clearly. Then in Abacus, they have given different file extension. For example, we are having .cae, so it is like our model file. .inp means like we are calling input file for this our problem. Input file for solver. Then .odb, like this is output file. After running simulation, we will get our odb file. In this odb file, we are going to store our all information. Then these are like log and message file .msg, .sta, .dat. So by looking these all file extension, directly we can see which file we are going to check. In the last they are similarly they are having like website, and on that website we can check all the information like learning resource from similar document. We can get all the information. So till now, what I told, like first we have to design our model in CAD. Then we have to assign property. Then we have to do meshing. Then assembly. Then we have to apply our boundary condition. Then we have to assign solver. In the last, we are going to check or like we are going to study result. Okay. So sir, like till now.